Greetings, coders. In this video, we're going to talk about using recursion in Scheme. What is recursion? You've covered it in the Java classes 110 and 205, but we're going to review it a little bit. And let's start with this analogy. Let's say that you're in a line and you want to find out if you're where you are in this line and how long it's going to take you to get to the front of the line. Now, you could try to brute force this by walking forward and counting each person as you go. But ultimately, if you're like me, you're relatively lazy. And so you want to find the easiest way or the laziest way to find out how many people are in front of you. And you come up with this idea that, hey, I could just ask the person in front of me and say, what number are you? And they probably won't know, but they could ask the person in front of them, who could then in turn ask the person in front of them, moving all the way up until you get to the person that's at the ATM. And then they can send that information back and you can add 1 to each one of those values once you reach the first person. The first person, number 1, would be your base case. And then it would return back and each person would add 1 to that. Now the person behind would know that they're 2 and the person behind that 3 and so on until it carries all the way back to you. And this is the basic idea of how recursion works and what we'll be leveraging to do it in this class. I've been talking over this video here that is a really good introduction to recursion if you don't feel like you have a good grasp on it. However, it is about 2 hours long. I just wanted to use it for its example that it starts off with. And I like their approach here that when you're thinking about recursion, it's what is the least amount of work I can do and when does the process complete? What is the base case? Where can we start from and build back with? When we're wanting to solve a problem with recursion, we want to first ask ourselves, what is the base case? And then what are the changes between each subsequent recursive call that is going to move us towards the base case so that it changes our current value, making progress towards this base case. Let's work through an example where we have a recursive function that's going to reverse a string. And our example is going to be reversing the string hello. So the base case would be the last letter of the string, the O. And then each character will be added to the end of the string as we're coming back out. And so we would start with O, get all the way to O, and then that's the first one we put onto our returning string as we're coming back out. And then it builds to the L, to the L, to the E, and then to the H. So our base case is when we are at the end of the string, and then we recurse, finding each next character until we reach that base case. And so if we were doing reverse on hello, the first call would be broken up into rev LO. So we've gotten rid of the first character. The first character has been appended here to the end of the string. This is going to return back whatever else comes out of the recursive calls. And then we're popping off each letter as we go. And then we reach an empty string as a result. So we come back out and we return nothing. Nothing plus 0, our O is going to be O. So O is returned, and now we add L to it. And so we have OL because we're adding to the end of the string. We're adding another L to the end of the string. So we return back OLL and add E to it. Then we have Ollie, OLLE, and then we add H to it. And we have Olay. Now, what does this look like in Scheme? So here's a Scheme function that will reverse a string that's passed into it called rev, and it receives a string. And so the first thing that happens is an if statement. If the string is an empty string, then return empty string. This is our base case. And then our recursive case will execute a string append that receives everything that came before it, the recursive calls, and then adds in the current first letter of the string. So on this first call, we have rev ELLO. That's this substring starting from the index 1, which would be the second character, ELLO, and then it keeps and adds to the end of whatever string is coming back, it adds the H. And then we have LLO plus E, LO plus L, O plus L. And then we start off with the empty. So this is going to work the same way as it did. We've reached our base case of an empty string, and now we start coming back out of the hole. And so we return empty string, and then we return empty string plus O, which is O, and then we return OL, and then we add another L to it, so we're returning OLL, and then we return the OLL plus the E, and we get Ollie, and then we return the H to get OLET. So another common recursive function that we'll see is calculating factorial. So in the case of factorial, what is the base case? The base case is going to be when we reach 1. And the change between each call is going to be decrementing whatever value was given in until it reaches 1. And this is what the method looks like, or an implementation of the method looks like in Scheme. We call it fact, and we pass in a number. And then if our base case here, if the number is less than or equal to 1, we return 1. Otherwise, we multiply the current M value times whatever has come before it. So on the stack, the first time through, we put the 5 out here to be used later when we're coming back. And we call rev again with 5 minus 1. This is what's changing each time is the minus 1, reducing us down until we get 1. We return 1. We multiply 1 here by 2. Multiply 2 times 3 to get 6. Multiply 6 times 4 to get 24. And then we multiply 24 times 5 to get our answer, which is 120. And that's it for this video.